Okay, we just did this. We got y equals, k plus tan theta, and we got x equals k plus tan theta divided by tan theta. What they're asking now is find an expression for the area. And I think I can do that, and I'll tell you why. Area, let me turn my phone off. Sorry about that. Okay, so area is equal to 1/2. Going back to the triangle, by the way, this triangle over here, base of it's going to be just the x-coordinate of the x-intercept. And then the height of that, this is the triangle they're talking about, would be the y-coordinate of the y-intercept. And that's going to be y. And let's write this one down. 1/2 times the x. What's the x? Is k plus tan theta over tan theta times k plus tan theta. All right, let's just put some parentheses on these things over here to make it clear. I'm going to simplify that, and a equals, well, it looks like 2 thetas on the bottom. And then I get, let's see, k plus tangent theta. That whole thing's being squared now. So a couple of things we got now. We got an area, and you're going to keep reading it. It's a fine expression. This is A now. We're on A. And this was just number 1, by the way, the first thing they asked me about, and I got that. So we're on A now. So let me just read again. Find the expression for area. We did that. In terms of k and theta, it's certainly done. It says the 0 is the origin. I got that part covered. You were given that as theta varies. That's true. So what does this mean? This is a function of theta, not a function of k, by the way. K is fixed. So a theta is actually equal to k plus tangent theta. This whole thing's being squared over 2 tangent theta. So they did ask for us to put a box in this. We're done with that. And keep reading it, though. It says A has a minimum value. That seems reasonable, by the way, because as this thing pitches around, we're expecting to get a minimum value to that. And also, that it's an unbounded maximum. If you think about it, that thing moving around, it's kind of bizarre to even think about that, but there's a minimum value on this thing over here. And this is where I'm going to say I'm probably going to have to use calculus. Right? I don't see any other way of doing it. So what are we going to do over here? For me to use calculus, I don't want to take the derivative of this thing right away. So what I want to do is I want to simplify it a little bit. And yeah, I know it's difficult, but I want to write down a simpler form of this over here because I want to take the derivative. So the bottom line is what you can do about that. The top would be k squared plus, let's see, 2k tan theta plus tangent squared theta. All right, I got to be careful because I want to take a derivative and I don't want to make any mistakes with this. So the first guy I'm getting is going to be k squared over 2, and 1 over tangent is going to be the cotangent. It's easier to take the derivative of that than the quotient, by the way. Next one's going to be plus, well, it's going to be 2k tan theta over 2 tan theta. So the tan thetas would cancel, the 2's would cancel off. You just get a k. All right, it's a middle term. Again, tan theta disappears and 2 disappears, you get a k. Last but not least, what do you get? Well, let's take a look at that. You're going to get tan theta, because one of the tans would cancel off over 2. All right? So I got to take the derivative, and I'm going to point out that I don't want to say, maybe you can't remember derivative of everything, but I'm going to say d theta of tangent theta is secant squared theta. And I'm just going to go through derivation of the cotangent. And that's going to be, just write it down for you, it's d theta cotangent theta. And that's the same thing as d theta. I'm just doing a derivation for you. This is going to be cosine theta over sine theta. Whoops, getting low in power. Got to be quick with this. So I could take that derivative with the quotient rule. So sine squared, sine theta times minus sine theta, so sine squared minus cosine theta times cosine theta, which is cosine squared. So, someone said, oh, I remember that. It's minus 1 over sine squared, which is going to be cosecant. All right? So I'm going to say that's pretty easy to come up with. All right? We got two things over there. Let's write this down. A theta. Take its derivative. You get k squared over 2 times the derivative of cotangent. Well, we just did that. That's minus cosecant squared. I'm going to write that as, let's see, minus 1 over sine squared. The derivative of k with respect to theta is 0. K is a constant, by the way. And the derivative of tangent, secant squared. All right? Now, secant is, let's write this down. Secant squared theta over 2. All right, let's clean this up a little tiny bit and make sure I didn't do any mistakes over here. No, I don't think so. Let's keep going. A prime theta equals minus k squared 2 sine squared theta plus, well, you know what I'm going to do? I'll multiply top and bottom by sine squared. So I'm going to say 2 sine squared theta. I'm kind of looking at this over here and I'm wondering, that's really just, what is that going to be? 1 over cosine squared theta times sine squared theta. And I immediately recognize that to be the tangent squared. Well, things are shaping up a little bit. Let's write this down over here. And you get 2 sine squared theta. On top you get tangent squared theta minus k squared. I got the derivative, by the way. Now, of course, someone says, what are you going to do with this over here? I'm going to try to figure out a critical value for this thing over here. And it doesn't look that bad to do, and I'll tell you why. I'm on an interval for theta between 0 and pi over 2. So I can easily use the arctan function. Let's go through this. Where does this take on a 0? By the way, the 2 sine squared theta is always going to be a positive number on bottom. So I'm kind of worried about the top at this point. And what are you going to get? You can get the tangent of theta would have to equal k. All right, whatever k is, it'd have to equal that. Now, what I got to do is I got to do the arctan now. So what's theta going to be? Arc tan of k. All right, let me just think about it for a second. And I got to get the resulting area now. So I got this would be the minimal value over here. And let me just think about it a little bit. By the way, one way to think about this is the arctan of k is in here somewhere. And if you go towards the end point, I hope you realize that as the tangent goes towards pi over 2, it gets huge, by the way, when you square it. So it's up here somewhere, clearly a positive number. And when you go towards 0, right, what does that mean? That this is going to be increasing over here, going up. And when you go below this number, like go towards the 0, by the way, the tan gets incredibly small, by the way. And then you're looking at this curve. It's going to be a negative thing. So it's going to be a minimum over here. All right? But anyway, I think I can do the area now. And so how do you do that? Well, I'm going to go back to the area function. And this is the area function over here. I'm going to write this down now. So the area is a function of theta. And that area function, again, is, we just wrote it down, right? So the area is going to be k plus tangent theta squared over 2 tangent theta. And we're going to write down A of arctan now of k. Wow, that's crazy looking. What's this going to be? K plus, well, let's see. If theta is going to be arctan of k, the tan of that would just be k. I'm going to square that now. On bottom is going to be 2k. And I think I can write area down now. On top you get k squared. Make sure I make too many errors over here. Make sure I copied down the right thing though, and make sure I did that. So k plus tan theta, quantity squared. The bottom is 2 tan theta. That's up here. And then k plus k. Oh, I'm sorry. You know, I made a mistake. So it's, I got to erase this over here. I'm glad I looked back over my work, by the way. It's 2k squared over 2k, which is just 2k. All right? So this is going to be the resulting area. This is the minimal area. Okay, I'm running really low on power. I want to just make sure I'm reading over the question and got the two things, what they asked for right now. Number one, going back to the question, what they asked for, read it to you again, straight line pass through the point. We'll go back to the top, by the way. Yeah, I did that, and they asked for, find, in terms of theta and k, the coordinates x and y, the x, y, x and y. I got that. And then I did A. A was find the equation of the area of that triangle. I got that. And they also asked about A as a minimum value, find the expression in terms of K for the minimum value. And we also found the minimum value, by the way. Minimum value is over here, 2K. We'll go on to the next question once I charge the computer. Thank you.